We are doing questions on practical electricity, and we have first made the concept that a fuse is always connected in the live wire and a switch should also be in the live wire. So that is why we selected option A. When a three-pin plug is wired, there should be a fuse in the live wire, and the cable cover should be covering the cable cover should be under the clip S. Now, presently, we are doing question number 3. A 100-watt lamp is switched on for 5 hours each day for 3 weeks. For 3 weeks. One unit in physics, the cost of one unit, actually 1 unit means 1 kilowatt hour. And we want to make a bill of it. So when you calculate energy is equal to power into time, I have divided 100 by 1000 so it can convert into kilowatt, and I'm multiplying it with 15. So can you please do this calculation for me? I'm getting 1.5 kilowatt hour, and 1.5 into dollar 0.24.
The answer is A, 0.36.
0.36. Late reply, but still the reply is there. 0.36. Please reply in time. The answer is A. The diagram shows the information found on an electric kettle. I have discussed this question with you in the class. This is an example of a tricky question which apparently shows some calculation, but it is not a calculation topic. You have to read the question. No, do not mark the answer so quickly, but first discuss. Answer is right, but frequency is measured in hertz. Frequency is measured in hertz. So frequency is given directly. So as you have said, answer is A. This is a tricky question. Actually, you're not supposed to do any calculation. You just have to mark the answer. Which diagram shows a lamp wired correctly to the main supply in a house? Remember, switches, fuses, circuit breakers are always connected in live. Fuses, circuit breakers, switches are all connected in live wire. So now you can see the options. Which option looks fine to you? This is the theory. Now tell what should be the answer. Hamad, please reply. What is the answer? I have given all the hints. Just or
1 minute.
please reply because MCQ time is very limited. This is the live wire. Look, this is the switch. This is the fuse. They all are connected in the live wire. Good. See, 1 kilowatt hour of energy cost 0.24. How much does it cost to run a 2 kilowatt heater for 3 hours? They have given us the power. They have given us the time in hours. So what is the formula? Energy is equal to power into time. So I have a 2 kilowatt heater and I'm running it for 3. It is 6 kilowatt hour. Do the calculation with me. And what is the ratio? 1 kilowatt hour is costing $0.24. So do this calculation, get the answer for me. Please do the calculation. 0.24 into 6. 0.24 into 6. 1.44. You're taking much time, a lot of time to do a calculation. Please do it quickly. Exams are, MCQs are quick answers. But anyways, I have done it. Good. Now, this topic is not in course anymore, the color code one. An appliance uses a current of 3 ampere. Which row is correct for the fuse in this application? Fuse is always connected in the live wire. Fuse is always connected in the live wire. So the appliance itself is 3 ampere. So if a 3 ampere device is there, then obviously you can put a fuse of 5 ampere. Live wire is compulsory because fuse is always connected in a live wire, and fuse should be a bit higher in value than the line current. The table contains, this is again a question, again a topic which is not required now. Which unit measures the energy input to an electrical appliance? Energy. Ampere is a unit of current. Kilowatt hour is a unit of energy. If you have observed the notes, volt is a unit of voltage. Watt is a unit of power. Now, I have written full working for you, and now you have to tell me the answer.
We can measure the energy into ampere.
Look the word energy. I have written everything for you.
Kilowatt hour. Kilowatt hour.
Yes, I have written it, and then you have to give the right answer at least. An electric lamp is marked 0.5 ampere. This is current. it is connected to a socket marked 30 ampere maximum. So the socket board can support maximum 30 ampere and a lamp is happy at 0.5 ampere. So 0.5 ampere should not be the answer. Current should not be. Obviously, A is not possible. B, D is even crossing the socket current. Now B and C. The device is of 0.5 ampere.
Three.
3 ampere is a good choice because it is it's a bit more than, it is bit more than 0.5 ampere. Now the diagram represents part of a household circuit containing an electric kettle, which row correctly identifies the wire X and Y. The switch is always in the live. There is a connection with the metal casing, so that should be the earth wire. So W should be the live wire which contains the switch, and X should be the neutral wire. The switch is always in the live wire. Five electrical appliances are connected to the same socket and there is a very large current. Why is this dangerous? He has connected 5 devices. This is something in our country also we make this mistake of connecting number of devices in one extension. Why is this dangerous? The fuses blow in the appliances. There is a greater risk of an electric shock. There is overheating in each appliance. There is overheating in the socket.
Meeting in the socket.
Overheating in the socket is a good choice because number of devices are connected. What causes the fuse to blow in a main electric circuit? When live wire touches the earth wire, the circuit can be tripped. The fuse will blow when current increases. Actually, fuse always blow up when a circuit contains lot of current. So it should be the case the live wire touches the earth wire.
Okay.
A water heater uses 6 kilowatt of electrical power when connected to a 240 volt supply, which fuse is most suitable. So we have a power and we have voltage, but we should first find the current. 6,000 upon 240. So please, how much, what answer coming? 6,000 upon 240? 6,000 upon 240. I'm getting 25 ampere. Then C is fine because it's greater than 25. A lamp connected, to a 12 volt. Remember to remove this annotation because it goes on the other letter. A lamp connected to a 12 volt supply converts energy at a rate of 36 watts. So this is power, this is voltage. How much energy will be converted in 10 seconds? So we have a formula, energy is equal to power into time. So I have done the calculation here and I'm getting part number D. An immersion heater is labeled 12 volt and power is 60 watt. What is the current in the heater when connected to a 12 volt supply? The formula P is equal to VI. And when you rearrange it, E is equal to P upon V. The power is 60 and the voltage is 12. So I have done the calculation and I'm getting 5 ampere. A lamp is rated 60 watt. This is power, this is voltage. What is the current in the lamp? What is the current in the lamp when used normally? Sixty upon
4.0.
60 upon 240.
Yeah.
60 upon 240, I'm getting 0.25 ampere. The cost of electricity is 16 cent per kilowatt hour. What is the cost of using 3 kilowatt heater for 4 hours? It's a billing purpose. When you make a bill for electricity, you have to multiply the cost in the kilowatt hour. Kilowatt hour is a unit of energy. Now you have a 3 kilowatt heater, electricity device heater, and time is 4. Now how we calculate energy? Power into time. It is 3 and look at this working 4. 3 kilowatt. So it means the answer will be 12 kilowatt hour. 1 kilowatt hour means 1 unit. 1 unit is costing 16 cent. So the cost will be 12 into 16. See the options which are coming up here. Look at this working.
C is the correct answer.
Yes, C is the right answer. Good. Then the diagram shows a circuit. The lamp is a 12-volt lamp and is working at normal brightness. What are the readings on the meter? We need reading for voltmeter and reading for ammeter. The lamp is 12 watt. Power is 12 watts. Okay. The power has a formula VI. So apply this formula 6 into 0.5. I will get 3 watt. I need to get 12 watt. 12 into 0.5. I'm getting 6 watt. 12 into 1 is 12 watt. Now it's matching. A lamp rated 6 volt, 2 ampere is switched on for 60 seconds. How much energy is used? This is the voltage, this is the current, and this is the time. We first write down the formula. E is equal to VIT. So 6 into 2 into 60. So you please multiply this. Look at this working. The current in a filament lamp is 0.25 ampere. When working normally, the lamp is connected to a plug and the mains AC supply. When the lamp is switched on, it does not light. What is the possible cause for this? Now we have a lamp and the lamp is connected to a plug. The earth wire in the plug is not connected. Earth wire has nothing to do with the starting and switching off. So if earth wire is not connected, it doesn't matter. The fuse in the plug is 3 ampere, but fuse is greater than 3 ampere. 3 ampere is greater than 0.25 ampere. So it should work. The lamp only works on a DC. This is wrong. Our household lamps are all on AC. The live wire in the plug is not connected. This is possible because if live wire is not connected, if the live wire is not connected, then the device won't work.
This question, can you explain me again?
It's a concept. I have explained every part. Earth wire has not actually linking with the circuit. If earth wire is not there, it doesn't matter. The fuse is 3 ampere. 3 ampere is more than 0.2 and 5 ampere. So it should work. The lamp work on only on DC. This is wrong because lamps work on AC also. The last part makes sense because the live wire in the plug, it is possible that the live wire is not connected, so the lamp is not working. Which appliance used on a 240-volt supply is most likely to burn out its fuse? Now we have a circuit here, and look at the circuit. The voltage is 240 volt. Appliance is 100 watt. Power is there. So let's calculate the current. What is the formula? Power is equal to VI and I is equal to P upon V. Hundred upon 240. Then for second circuit, 1000 upon 240. Then now I have done all the calculations. Hundred upon divided by 240, 0.416.
I'm getting the answer as
1000 upon 240.
uh,
Then 2000 upon 240, divide all of them. And 3000 upon 240. 12.5. Now compare all the answers. Most likely to burn out, where the current exceeds, where the current exceeds the fuse current. I have made calculation for all options. So where the current is exceeding the fuse current, where the current is exceeding the fuse current.
C. C.
Yes. Which quantity is measured in kilowatt hour? Charge is measured in coulomb, current is measured in ampere, energy is measured in joule, power is measured in watt. Energy is measured in joule and also measured in kilowatt hour.
Yes. Which quantity is measured in energy? C. C.
The metal case of an electric heater is earth. The plug to the heater contains a 5 ampere fuse. There is a current of 4 ampere when the heater works normally. Fuse is 5 ampere. Normally the current is 4 ampere. The cable to the heater becomes so warm that the live wire makes electrical contact with the case.
Okay.
He has connected the metal case with the earth. So when it is connected to the earth, current will increase in the circuit and it will switch off the circuit. The fuse will melt. The fuse will melt and stop the circuit. This is the purpose of earth wire. Many electrical appliances have metal cases to prevent the case from becoming live. With the possibility of an electric shock, the earth wire of the electric cable is attached to the case. How does the earth wire prevent an electric shock? You haven't done this topic with me yet, so I'll leave it. A battery is used to light a 24-watt heat electric lamp. The battery provides a charge. This is Q, this is P, and this is P. What is the potential difference across the lamp?
This is,
First, write down the formula.
okay.
This is the formula. Now see the working and solve it.
I think the answer will be 24, 20 times.
What is the
So, yeah,
answer? What did you get when you are calculating this value? What answer you are getting? 24 into 60 upon 120. It should be 12.
yes, 12. Yeah, I'm getting 12.
A student has a chain of 20 lamps. These are wired in series and connected to the main. One lamp blows and all the others go out. The student wants to find the faulty lamp and replace it. Where should the student begin? Anywhere, because the current was the same in the each lamp. That makes sense. At the live end of the chain, because the current was greater there, this is wrong. Current is in series is the same. At the middle, because the current was greater there, this is wrong again. In series, current is always the same. At the neutral end of the chain, because the current was least there, this is also wrong. Actually, current is the same at every point in a series circuit.
Uh,
We have voltage, we have power. He is asking to select a fuse. So power is equal to VI.
V
I
I
is
I
equal
is equal to P divided by V. So 240 divided by
So what is 240 divided by 2500? Try to learn to do these calculations quickly, because I always have to wait and you are doing a small division.
0.096. 0.096.
Right, but try to do it quickly, because this is not a big, only have to divide on a calculator. 0.096 is a very small current. So the smallest current fuse is here. A plug is wrongly wired as shown. It is connected to an old vacuum cleaner which has a metal case. What is the effect of using the plug wired in this way? This is a colored wire system, so I'm leaving it because the color of the wire is not required anymore. Which costs the most if operated from the same main supply? For calculate energy. Power must be in kilowatt. When you calculate energy in this topic, the power must be in kilowatt, power must be in kilowatt, and time must be in hour.
Yes.
So now you have to complete this working for me. He says the most, you have to find the biggest number which costs the most. So A, B, C, D, which answer is coming the biggest? Sorry, what answer?
Last one.
Acha, 1000. Okay. Sure. Let's keep it up to here and we will inshallah continue this in our next class. Allah Hafiz.